are you doing? Every time I come in here, you're doing something bizarre.
You know what, Mr. Maxwell? This is a map of the world.
Okay.
But do you know the world wasn't always like this? Even when I was young. Even when I was young.
It's changed in your time?
The continents were here, but not exactly like this. It all goes back to theories. And theories, of course, for the most part, are pretty solid. However, sometimes people have problems with theories.
Yeah, and it's oftentimes based off of the technology that's available at the time. And as our technology advances and we learn about different things, you know, some theories are proved to be correct, to become laws. Other theories are disproven. And then
one of my favorite theories is the theories of Pangea.
And this idea was from Alfred Wegener in the early 1900s. This idea that at one time all the continents, all of the lands were together. Okay? And he called this land Pangea, meaning all lands. Okay? It's a kind of simple term. All lands, Pangea. And if you look at the image that we have here of Pangea, okay, you can see that this is what they believe that the landmass appeared to look like. Okay? Where you can see North America, Africa, South America all together. You have Australia and Antarctica together, with the Eurasian continent at the North Polar region. And they base this on some different evidence. Okay? Obviously the first one being that everything appeared to look like a jigsaw. As you can see at the map that Mr. Reynolds has in front of him, okay, it appears that all some of these continents fit into place. Okay, and that was, you know, the driving force of Wegener's theory, is that they fit together. Okay, and there has to be a reason for that. Okay, the second part is that some of the land features, including similar rock structures and types of rocks, appear on different continents that have been separated by oceans. For example, the Appalachian Mountain Range actually ends in Europe, not in North America like we think it does. It actually continues on.
This Appalachian Mountain Range that runs along the eastern seaboard, it actually went up and across and then down through France and Italy and so on. Huh?
And the only way that happens is if those continents were together. Also, they find evidence of the same exact rock material in Africa and in South America. And the only way that could happen is if those rocks formed at the same exact time, at the same exact place. Okay, so that's how they know that they were once together. Also, there's fossils like the Mesosaurus, which you'll be doing a worksheet on. You know, that's a freshwater reptile. And they find fossils of that organism both in South America and in Africa.
And they didn't swim across the salt water to get there.
It's a freshwater organism. Okay, there's no way they could swim across that. And there's other organisms, not just that one, where it's the case. And then you have climate similarities. Okay, they actually have fossil records of fossilized ferns. Okay, it's a plant that really grows like temperate regions. Okay, they found those fossils in Australia, Antarctica, and Africa. There's no way that a fern could survive in polar regions. Okay, so again, it's about being together and those land masses. Now, initially, Wegener's theory was rejected because he couldn't explain the force needed to push or pull the continents. You know, scientists, you know, they want to know, well, if this is the case, how did it happen? Why is it moved to its current location? You have to have a reason why or how this occurs. And Wegener couldn't come up with that idea. Okay? And it wasn't until the mid-1900s that they were able to kind of really see that this, in fact, does happen. Now, what we believe to have happened is that the land masses have changed location over time. And it's a slow process. So Pangea being about 225 million years ago, and then over time, the continents have separated and moved out. Okay, so you see that there's not always North America and South America being connected, and then over time, they've come together. And the continents move into the present-day location. And we know today that these continents are still moving. Okay, North America and Europe, they're actually moving about 2.5, 3 centimeters a year farther apart.
And remember, 2.5 centimeters a year to you is like, wow, that's nothing. But over millions of years, geologic time, that's a lot of movement.
Now,
so can you go back to that last slide, Mr. Maxwell? Because I have a question for the audience that are watching this.
Yay!
If they're spreading apart, and this is the modern day version of what's going on, what do you think a couple 100 million years from now the Earth will look like? Where will the continents go? Will they keep traveling around to the other side and create Pangea again?
But in a different direction. So you would have Pangea, but you wouldn't have South America and Africa being together there, but rather the backsides.
So these continents really are floating like on a waterbed, only instead of floating on the oceans, they're floating on this hot magma mantle. Right, Mr. Maxwell?
Yes, sir. And now I'm going to show an image of what's happening as Mr. Reynolds changes the notes. Okay, so we have what's called sea floor spreading. And they found out that this occurs in the mid-1900s, again, with that technology piece, with the invention and utilization of sonar. And what they've actually discovered is that magma comes up, and you can see here, through the seafloor. And it spreads apart. It basically is being ripped apart as that magma comes up through. And so it's taking this crust, these plates, and moving them away from this area. Now all of this ocean floor is covered by water. Okay, so water is going to cool that magma very quickly. So as the magma comes up through, it's going to cool. That molten rock cools, and when it gets cooler, it hardens, and it forms new rock material. And you're basically getting underwater mountains. And this process is occurring, like I said, in the Atlantic Ocean, about 3 centimeters per year, it's separating. So so these plates are moving apart, and you're getting this mountain material building up. Some evidence of this, besides just the ocean floor, that's how we have Iceland. Okay, Iceland is a mountain that has actually reached the surface of the ocean, and that's what islands are. They are mountains that have grown above the ocean floor. Okay, and islands can form in different ways, but in our Atlantic Ocean, this is how they form, through this crack in the earth, the separating of the plates, and this seafloor spreading. Okay, so if you look for where Mr. Reynolds is writing this down, so you can copy this down for yourselves, again, it's that 1900s. It's about scientists mapping out that ocean floor using sonar. It's always that quest to learn, okay, to understand the unknown. And then in that process, they discover those underwater mountain ranges. And then, as I said, as time's gone past and technology's improved, they actually are able to observe molten rock material rising from the mantle. It erupts through and just separates that plate. And we have underwater mountain chains. And it's actually called the Mid-Atlantic Ridge, the mountain range that is formed in the Atlantic Ocean. Okay? So that is the concept of seafloor spreading.
There's a poster showing the Mid-Atlantic Range right up here, Mr. Maxwell.
Yeah, so you can see here how literally right in the middle of all those continents, you have the break in the Earth's crust. And it's every year, those continents are getting farther and farther apart.
So each year it gets further and further to travel to Europe? Is that what you're suggesting?
Yes. Again, for us, is 3 centimeters significant? No. Geologically, over thousands and millions of years, it makes a difference.
So if you were to remove all the water in the oceans, That'd be a heck of a mess. But you would see rivers and valleys just like on land.
Yeah, it's just like the landscape on land. It's not nice and flat across the world, across the ocean floor. You've got hills, valleys, and mountains.
So if you were an enemy submarine coming over from this area, you would hide inside those valleys.
And that was one of the reasons why they started mapping out the ocean floor. So we use
for military
purposes. Mm-hmm. Okay, and that seafloor spreading and what was once a theory but has now been proven, also because of GPS, the idea of continental drift.